All right, guys, so we're going to be going over some conics. These are conics found from previous finals. So these are actual finals questions that Slick gave. So it's good to go over those. So let's start with this one. And I'm going to call on people to help me out for it. So first off, let's go to Anita. Anita, how do we get the equation from general form to standard form?
You bring all the same factors together, if that makes sense. So you do 9x squared, and then you would leave a space, and then you do 4y squared minus 4y, and then I would add the third. Is that 35 to the other side?
Yeah, so there's no other x. That's so weird, but it'll be okay. And then you said 4y squared minus 4y, and then on the other side, it'll be positive 35. Now this is kind of crazy because usually we see another x here. So if I don't see another x, do we need to complete the square? The answer is
I don't believe so.
no.
I don't believe
Okay.
so.
Now, keep going on this, Anita. If I'm going to complete the square with the y's, what do I have to do first?
You factor anything that you could factor. So I would bring out the 4, and I would leave you with y squared minus 1y. And then you complete the square. So it would be 9x squared plus 4 times y minus 1. Huh?
Yeah, it's going to be 1/2. Good
Okay,
job. And then what's
squared.
1/2 squared?
1/4.
You're right. So here, now, this is where it's okay because now I'm going to have to bring the 1/4 there. But remember, that's really 1/4 times 4, which is going to turn into 1. So this is going to turn into 36, which is nice. All right, great job, Anita. We're almost done. What do I just need to do last, guys? We want it to be a 1, so we divide by.
Sorry.
You're good. I'm just kind of going a little faster. Okay, so reducing, this is x squared over 4. And then this will be y minus 1/2 squared over 9 is equal to 1. Awesome. Thanks for your help, Anita. All right, now let's go to, how about, who's the next person I see on here? Ashley, how would I find the center from that equation?
You look at your x and y, so your center would be 0, 1/2.
Good job. Let's actually label that on here. Oh, sorry, that's 0, and then 1/2 is going to be right there. And I'm going to put a C for center, and that's at 0, 1/2. Okay, now Ashley, is this going to be a Bob the tomato or a Larry the cucumber? Is it opening up more in the X direction or more in the Y direction?
X.
How much is it opening up in the X direction?
By 2.
Good, so let's go, so from here, I'm going to change colors. From the center, let's go out 2, so there's 1, 2. And then from this one, let's go out 2. And then how much are we going to go up and down in the Y direction?
3.
All right, so now I want to label these because it asks me to label them, okay? And now note, so one thing to just point out, find the vertices along the major axis. So it's basically saying we don't need to know the co-vertices, but we're okay. So guys, was this opening up more on the X or the Y? And it was actually along the X axis. This line right here, this would be our major axis. And that's going to be where the foci are going to be located. So our vertices are going to be the point 0, and we went up 1, 2, 3.5. So 3.5 is like 7/2, right? And then we went negative, and it's going negative 1, 2.5. So that would be negative 5/2. Or if you put like 2.5, that's fine too. So that's going to be a vertice at 0, and I'll just write it as 7/2 since that's what I did before. And this is going to be another vertice at 0 and -5/2. Now, does it say anywhere on here about finding the foci? I don't see anything. So that's going to be my ellipse. If we did want to find the foci, we would use equation c is equal to the square root. And now the question is, do we do a squared minus b squared or b squared minus a squared? And you just need to say, well, which one's bigger, 4 the 9? And a goes with x, b goes with y. So we would do b squared minus a squared. So this would be the square root of 9 minus 4, which is the square root of 5. So if I were to go up the square root of 5, which is like 2 point something or another, there would be a focus here. If I was going to go down from the center 2 point something or another, that would give me the other focus. Didn't ask for it though, but that's how you do it. All right, so there's an ellipse question. Do you have any questions on how we got the equation or graphed it?
Just to clarify, so depending on the equation on which it opens up, let's say it opens on y, that determines your major axis?
Yeah, okay, good question. So the whichever number is bigger in your denominator, that's going to determine where your major axis is. So in this case, since 9 was bigger than 4, the major axis is going to be a vertical line. It's going to open up more in the y direction. So it's going to be, in this case, it was the y-axis.
Okay.
But if we looked at a different one and x was bigger, then the major axis would be parallel to the x-axis because it opens up more in the x direction. So good, thanks for asking a question. Any other questions before we go on to a hyperbola? No? All right. I'm going to go up to this problem right here. Now, I like this one because it doesn't give you necessarily, it doesn't give you like the equation. You have to figure it out. It just gives you some information. So let's actually graph what we got here. A hyperbola, so it tells us it's a hyperbola, has vertices at 3, 1 and -3, 1. So there's 3, 1 and here's -3, 1. It also has a focus at 5, 1. Now, believe it or not, that's enough information for us to know that this is a hyperbola and to figure out everything else about it. So I'm going to pause and we're going to have Jocelyn. So Jocelyn, what I want you to do is to explain how, based on those points, we can figure out where the center of this hyperbola is going to be.
I'm not sure how to find that.
I have to turn up my sound so I can hear you. Okay, well, let me give you a clue here. This is going to be symmetric. So if this is one of the, what did we say this was? This was a vertice, and this is a vertice, and this is a focus. Kind of ignore the focus for now, but where is the middle of those vertices?
It's 0, 1.
Yeah, there you go. That's going to be the center. And it's good to know where the center is because we have to shift our graph to 0, 1. So there we go. Thanks, Jocelyn. Now I'm going to ask Carmela, can you tell me how we'd figure out where the other focus is?
Carmela's internet is like really laggy, so she's
okay.
not really seeing anything right now.
That's all right. Well, can you fill in for her, Brittany?
Yeah. Wait, what did you just ask?
So if one of the focus is over here at 5, 1, where would the other focus be?
It would be at it'd be at 5, -5, 1.
Negative 5, 1. Great, thank you. So there's our other focus. So keep in mind that these are symmetric, so they're evenly spaced out, right? Now, that'll help us in figuring out the h and k, right? Because h is how much we go in the x direction and k is how much we go in the y direction. But now I need to figure out a and b. A is going to be how far we go in the x direction to get to our vertices. So from the center, I went right 3 and I went left 3, so A is 3. And we were able to figure out that C, which relates to the distance to the foci, was 5, so it went over 1, 2, 3, 4, 5. But we don't know what B is. So someone unmute and tell me, how are we going to figure out what B is for our equation here?
You could do c squared equals a squared minus, or is it plus? Sorry, I don't know.
In this
Plus,
case,
okay.
with hyperbolas, it's plus. And that's why, so let me show you a quick, let's see, where are we? If you look at your formula sheet with your hyperbolas right here, it'll give you that one versus on your ellipses, it gives you those. So you don't have to memorize them, you just have to refer back to your formula sheet and you'll be okay. But yeah, we'll use a Pythagorean theorem here and say, okay, if this is 5 and this is 3, what will B be? Well, that's 25, 16. Let me erase that. So if I subtract 16, I get 9 is equal to B squared. So that gives me B is 3.
Wait, I'm confused where 16 came from.
Oh, wait. You're right. I'm doing this backwards. So hold on real quick. What did we say A was? A was 3 squared. I was like solving it in my head already and I jumped ahead. Sorry, that should be 9. And 25 minus 9 is 16. Sorry, I got a little mixed up. Thanks for calling me out there. So B is actually going to be 4. Is that a little better? Now, what that means is on my graph, B is going to be how much we go in the y direction, which is 1, 2, 3, 4. So that's one of our co-vertices, 1, 2, 3, 4. That's another, or wait, this is a hyperbola. So this is going to be used to make our rectangle. And I don't know how much they talked about the rectangle in the videos, but for me, the rectangle is like the big way that we figure out how to graph the asymptotes. So in the x direction, we went out 3 to figure out where the vertices were, but then we're going to go 4 up and down because we're going to make this little rectangle here. And by connecting the corners and making like an X, this is going to give us the asymptotes that the two branches of the graph are going to follow. Okay, let me show what I mean by that. I'm going to just draw a line from the center out the bottom. And I'm going to give another point so it's accurate here. So I'm going down 1, 2, 3, 4, and over 3. So then I'm going to go down 1, 2, 3, 4, over 1, 2, 3. There's another point. This one we're going to go up 4 and right 3. Now when I draw this line here, let's do a different color. It's going to go through the corners of the rectangle. And that's going to be an asymptote that our hyperbola is going to follow. Now we're going to do that same thing up here. We're going to go up 4 over 3. So up 1, 2, 3, 4 over 1, 2, 3. And then we go down 4 left 3. So down 4 left 3. And this will go through the corners of the box as well. And that is how we're going to graph our hyperbola here. Let's do a fancy color here. Let's do that one. It's going to follow along this asymptote, but then it's going to branch off and go through the vertex and then go back to the asymptote like that. Let's draw another one here. And there is the asymptotes, or the hyperbola based on the asymptotes. Okay, now I kind of jumped ahead to the graph. Sorry. Let's go back and let's finish writing our equation, okay? So the equation, we've got A, B, and now we've got our center. So I'm going to write it unsimplified here. Okay, so we're going to have x minus, the x didn't get shifted, so it's x minus 0 squared, and a is 3 squared, minus, we're going to do y minus k, so that's y minus 1. And then the b we said was 4, so 4 squared, and that'd be equal to 1. So if I wanted to write this out now, simplified, that'd be x squared over 9 minus quantity y minus 1 squared over 16 is equal to 1. We've already said the center was at 0, 1, so boom, there's the center. All right, that is a hyperbola question. Do you guys have any questions on how we did that? Questions? You guys still with me? You didn't push mute on your screen and are watching Netflix?
No, we're good. I'm good.
Brittany's good.
I'm good.
All right, cool, cool, cool. We're gonna go, if you do have a question, guys, call me out. What I wanna do now is to jump down a little bit. Here is another hyperbola question, but on this one, they actually give you the equation. So here's what I want you to do first. I want you to take, I'm gonna give you 2 minutes. And what I want you to do is, first off, I want you to figure out the shape of this. Is this going to be a Chanel or is this going to be an hourglass? And then I want you, after you figure that out, figure out where is this centered? What is the center? We're going to figure out the vertices. So where are your the vertices, okay? And then we're going to make the rectangle, and then we're going to graph it. And we'll also need to figure out where the focus or the foci are. So I'm going to give you 2 minutes, and what I want you to do is just get as far as you can, because really doing this on your own is where you're going to learn the most. So I'm going to set my screen down and give you 2 minutes. Good luck, and then we'll go over this together. All right, that was 2 minutes, guys. Let's see how you did. So, Christy, I want you to start off by telling me the shape. And after Christy, let's have Jared. if you'll tell me where the center was, and then who have I not called on yet? Where's my... We'll go from there. All right, Christy, you just start us out, okay?
It's an hourglass
How did you know that?
because B is bigger than A.
All right, so that's a good thought, but that only applies with the ellipses. So, and that's where it's good for us to review this to make sure we're on the same page. So with the ellipses, since they're adding, the order doesn't matter, right? You could put one first or one second, it wouldn't change. So that's when you look at the biggest. But for this one, it's all about which one is first, because you're subtracting, and with subtracting, the order does matter. So now, if the X is first, it's going to be actually the Chanel. If the Y is first, that's where we'll see the hourglass. So this one is actually going to be a Chanel. Did I show you guys? You guys know that Chanel makes that shape, right? I don't know if I ever showed you that. I'll show you another time. Does that make sense? Are we okay there?
Yes.
Okay, thanks. Jared, help me out. Where is this hyperbola? Where is the center going to be?
It's going to be at 3, -1.
Good job. I'm going to put that on my graph. 3, -1. Okay, now Ashley, how do I get the vertices?
So you look at your A, which is 9, and you take the square root, which is 3. So your vertices are going to be at 0, 1, and 6, 1.
So, and we'll put -1 and 6, -1. But yeah, that's the idea. Thank you, Ashley. Great. Now, when I'm going to get the rectangle, let's go back to Brittany. Brittany, how are we going to figure out how tall to make that rectangle?
That's when you look at the denominator for the x on that part. So that would be your a, and then you just square root that to get your, because it's a squared, so you square root it to get your a, and that would be 3.
Awesome. So we go 3 right or left, okay? What about up or down?
Oh, up or down, that's when you look at your y, and then 16 square, the square root of 16 is 4.
Awesome. So from here, I'm going to go up 1, 2, 3, 4, down 1, 2, 3, 4, and then we just make a box out of that. Okay, cool. Now, the reason why we need that box is it gives us the asymptote. So what I'm going to do is from the center, I'm going to figure out how much do I go up and over, which is up 4 over 3, up 1, 2, 3, 4 over 1, 2. It's right about there. And then I'm going to go down 4, 1, 2, 3, 4, back 1, 2, 3. When I connect this, this is going to be one of the asymptotes. And then we're going to do the same thing over for this guy. 1, 2, 3, 4, back 1, 2, 3, and then we can just draw this out. So those are the asymptotes. Now on this one, it didn't ask us to give the equation, but what if you were asked to write the equation of the asymptote? Well, you're just going to remember the equation of a line is y equals mx plus b. And all you need to figure out is the slope and the y-intercept. So for example, this first one that we drew, we said it goes up 4 over 3. So that would be y equals 4/3, because it's rise over run, x, and the y-intercept is -1, 2, 3, 4, 5. So 4/3 x minus 5. The other asymptote, it had a slope of -4/3 and a y-intercept of 3. So I'd write that's -4/3 x plus 3. Awesome. So then that gives us a lot of stuff, but Anita, can you hop on and then just tell us how we would figure out where the foci are at?
So to do the foci, you're going to do the c squared equals a squared plus b squared. So you're going to do the 9 plus 16 and then square root that, which would be 5.
Awesome.
And then you take from the center, left and right, and that'll be your foci. Foci. I don't know.
I switch them up all the time. I still don't know what I want to call it. So yeah, those are our two foci. So now I can graph it. Let's graph this with something awesome. We're going to make it bigger too. So now I'm traveling along, and then it's going to branch off and go like that. Same with this one. We're traveling along the asymptote, go through the vertex like that. And doesn't that look so pretty? Okay, so now going back here, what was the center? We already figured that out. That was 3, -1. Graph the hyperbola, plot and label the coordinates of the vertices, and draw the 2 oblique asymptotes. Didn't ask for the equation, but we got it. But please make sure when you do this, if it asks you to plot and label, we would want to say, stop moving here. We want to say this is like V1, or just put a vertex here and actually label it 0, -1. We kind of did that over here, but I want it to plot and label it, okay? So that's 6, -1. Make sure your graphs look really nice. Okay, do you guys have any questions on that hyperbola? Did it match what you guys did? Do you feel okay?
Yeah.
Yeah, I'm good too.
Okay, cool. I want to do just one last question, then we'll call that good, okay? We haven't done a parabola one, so let's just go over a parabola question, and then we'll call that good. I think I passed it, so where are you, parabola question? There we go. I have a typo here. It should be at -1, 2, and a directrix at x equals 1. Okay. So guys, now let's just do one with a parabola here. I'm going to use the graph above. But we want to write the equation of a parabola based on the fact that it has a vertex at -1, 2, so there's -1, 2, and a directrix at x equals 1. All right, so now the first thing I want you to do is I want someone to unmute and tell me which way is this parabola opening. Is it opening up, down, left, or right? And how do you know?
It's opening right because the direction, whatever it's called, is opening on the x-axis, not on the y.
Mm-hmm.
And it's facing to the right, so we're gonna go to the right.
So it is going to be facing, it's one of these two, but it's not going to be to the right because the directrix is going to be on the opposite side of it. And so this one is actually going to be going to the left. You know?
Yeah, that's what I meant.
All right. You're good. I say the wrong thing all the time. So it's going to be this one. It's opening to the left because we got the directrix right there. So now, thanks, Ashley. The next question is going to be, guys, if I'm looking at my formula sheet here, which of these two formulas, so these are both of your parabola ones. You've got this one here and this one here. Which one are we going to use if we want it to open to the left? Someone's just got to unmute and say it.
What do you use the y equation?
You would. Good job. If it's the x squared, it opens up or down. If it's the y squared, then we're going to use, it opens left or right. So I know the equation in general is going to look like this. Y minus k squared equals 4px minus h. Now we have the vertex already, so that's going to be that dot. So I know that this is going to be something like y minus 2 squared is equal to 4p, and then I'm going to do x minus the negative 1, so that'll be x plus 1. Make sure you put the negative 1 with the x and the 2 with the y. Okay, but what I still need to figure out here is p. That is going to be our focal length. So now, do any of you guys, based off what we have so far, do you think you know what p is going to be? Just someone unmute and tell me what you think. Oh man, you're gonna make me do this, guys? Well, let me give you one more. I'm gonna ask a different question. If this is my vertex and this is a directrix, where will the focus be? So I need someone to unmute and tell me where you think the focus will be based off the position of the vertex and the directrix.
Okay. If it's right there, then it would be. Is that 3 spaces?
Yeah. Isn't it?
Yeah.
Isn't it to the left?
To the left, and then it's like I can't see exactly, but it would be on the same Y. Yeah, right there.
All right, thank you. So yeah, so the distance from the vertex to the directrix is the same distance as the vertex to the focus, which is 1, 2, 1, 2. So what we're going to see here right here is that p, it's the focal length is 2, but a little more precise, since we're going to the left, we need to make it a negative 2. So p is going to equal negative 2. So now when I go to put that into the equation, it's just going to be quantity y minus 2 squared equals negative 8 quantity x plus 1. Now remember that the p, whatever that is, we times it by 4 to get the length of the lattice rectum. So that means I'm going to get 8, which means I'm going up 4, 1, 2, 3, 4, and I'm going down 4, 1, 2, 3, 4, and that will give me the key points I need to graph this. And if it asks for those endpoints, then label them, but that should be enough to get you full points for parabolas. So was that a good review on parabolas? Do you have any questions on that problem?
I'm good.
Yeah, I'm good too.
Okay, so cool. So here's what I'm going to say for you guys. Let me stop sharing that so I can see you. Whoa. Okay. Unpin. Okay, so what I need from you guys is to do a couple of things. Number one, I want you to finish your chapter 5 homework. That is going to be due after Thanksgiving on the 30th. But I want you to wrap it up sooner so you can take the chapter 5 quiz. If you haven't taken the 5.2, 5.4 quiz, do that first. The chapter 5 quiz covers everything. Remember that your project from chapter 4 is due on Monday. Now, we're going to start a new chapter and probably have to start doubling up on Friday. So I need you guys to make sure you're putting in time. I know it's taken up a lot of time, but the end is in sight. You've got less than like 2 months, and then we'll be done with this class. So put in the time and effort, and we'll be good. If you have other questions, you can stick around and ask those, but if not, then you are good to go. But thanks for joining. I appreciate you. I hope it helped. And then I will give you guys what you're doing on Friday. We won't be doing a Zoom meeting. It'll just be doing the meetings. All right?
Cool.
Yep, cool.
Yes.
Later,
Okay.
Silver.
See you later. Thank you.
Bye.
Thanks, Robin.
Hello.
Hi, Anita.
Did you see my email on the question on the hyperbolas?
Yes. Did you not get my email back?
Oh, sorry. I just haven't checked it because I was in all my other Zoom calls.
Well, let me hurry and check my sent. Oh, yeah. Okay, so give me a second. I need to see where is Anita. I thought I responded to it. Let me see. If it's the one I'm thinking of, then I already made like a video response to it. So let me hurry.
Yeah, the question was just on like asymptotes.
Oh,
don't
no,
know.
then I did not get. Oh, okay. Did you email me on Slack? Or did you email my granite one?
I think I emailed your. Oh, I don't think it's sent because of the pictures that I had on it.
Okay. Well,
So-
then no, I did
Okay.
not get your email.
Yeah. Okay.
I've gotten a couple emails recently and I made videos and sent them out, but I guess yours I did not get. So why don't you tell me which question, was it on multiple or just on one?
It was just like on the topic of like how to use like asymptotes, how to use asymptotes to form the equation of a hyperbola, I guess basically.
Oh, so it's like working backwards?
Yeah.
Oh, okay. Well, let me do this real quick. I'm going to share my screen with you. Let's see. How do I do that? Okay, you can see my screen now, right?
Yes.
Okay, so I'm going to pull up the homework and you tell me which problem it was, and then I will do I can walk us through it, okay?
Okay.
Or I can make a video on it and just send it out. Let me see. It depends. If it's one that I need a second to think about, then maybe I'll say, you know what, I'm gonna think about this. But if we can figure it out real quick together, then let's do that.
I know it's at like the end of the 20 questions, around like 17 to 20, one of those.
So this is 5-5.
Yeah.
All right, so let's see that it was towards the bottom. Okay. So that's the last question. That's 20.
Yeah. Mhm.
And it's not, is it this one 18?
I actually think I got that one right because I had the vertices. So I think it's 17. Yeah, 17.
All right, okay, so a hyperbola with equation blank. Okay, so here's what I'm gonna do. I'm going to, how do I stop recording? I'm gonna call,